Hello everyone. Today we are going to see about sterilization and disinfection. The contents are introduction, history, definition, classification, physical agents, chemical agents, then sterilization of instruments and conclusion. So first in that introduction, the microorganisms are present everywhere. Since they cause contamination, infection and decay, it becomes necessary to destroy and remove them from the material and from the areas. So the process of the sterilization is used in microbiology for prevention of contamination by extraneous organism, in surgery for the maintaining a sepsis, then in food and drug manufacture for the ensuring the safety from contamination organism and so on and so forth. Then in history, the principle of sterilization and disinfection had been laid down in early times. The reference to this is present even in the Bible. If a person touches anything ceremonially unclean, or whether the carcasses of unclean wild animals, or of the unclean livestock, or of unclean creatures that move along the ground, even though he is unaware of it, he has become the unclean and is guilty. So Alexander the Great used to boil water before drinking. So burning of the victims of plague in Venice in 16th century is an example of disinfection. So mummification was done to preserve the body from the microorganism degradation. Then definition of the sterilization. It is defined as process by which an article, surface or medium as free of all living organism, either in visit or spore state. Then disinfection, it means destruction or removal of all pathogenic organism or organism capable of giving rise to infection. Then asepsis. Asepsis indicates prevention of infection, usually by inhibiting the growth of bacteria in wound or tissue. Then septic, it is a chemical disinfectant which can be safely applied to live or tissue such as skin or mucous membrane surface, and are used to prevent infection by inhibiting the growth of bacteria. Then bacteriostatic agent, it prevents the multiplication of the bacteria. Then bactericidal agent, what are the bactericidal? They are able to kill the bacteria. So some agents that are used for the sterilization and disinfection, that is physical and chemical agents. So we are going to see about physical agents. First, in that sunlight, it poses appreciable bactericidal activity. Then play an important role in spontaneous sterilization under natural condition. Ultraviolet ray are the responsible for this sterilization. Then in tropical countries, they act as active germicidal effect. So drying. Next, drying. Moisture is essential for growth of bacteria. 4/5 of bacterial cell weight about consists the water. So drying therefore has a deleterious effect. It is unreliable and spore remains unaffected. So heat it is the most reliable method of the sterilization. Should be treatment should It should be treatment of choice unless it contraindicated. Then factors influencing the sterilization by heat. The nature of heat, the dry or moist heat, temperature and time, then number of microorganisms present, then characteristics of the organism such as species, strain, then sporing capacity, then type of material from which organism have to be eradicated. Then mechanism of action of the dry heat and moist heat. In dry heat, the protein denaturation takes place and oxidative damage also takes. Then toxic effect of elevated level of electrolyte. And in moist heat, there is a denaturation and coagulation of the protein. So steam has advantage due to the latent heat, and it destroys the spores. And bacteria more resistant to heat in completely moisture-free atmosphere. So in dry heat, first is dry heat. In dry heat, there is a flaming. Flaming, it is the inoculation loops or wires, tips of forceps and searing spatulas are held in Bunsen flame till they become red hot. So inoculation loops carrying infective material may be dip in the disinfectant before the flaming to prevent the spattering. So next is the incineration. Has limited application because it is destructive. Extremely useful for safely destroying materials such as contaminated cloth, animal carcasses and pathological material. Plastics such as PVC and polythene can be dealt with similarly, but polystyrene emits cloud of dense black smoke and hence should be autoclave. So this is a hot air oven. In a hot air oven, this is the most widely used method of sterilization by dry heat. The oven is heated by electricity with heating elements in the wall of chamber. Must be fitted with a fan. So hot air is a poor conductor of heat and its penetratability is poor. So it should not be overloaded. Proper arrangement of material should be done. A temperature of 160 degrees Celsius for 1 hour is required for complete penetration of the heat. Then glassware should be perfectly dry. Test tube and flask should be clean, dried and wrapped in paper or aluminum foil before sterilizing. So advantages are the sterilization carbon steel and other dental instruments which have fine cutting edge. And the disadvantage, it ruins the rubber and plastic object, weaken fabric and cotton plugs maybe get char. So oven should be allowed to cool for 2 hours before opening. Then come to the moist heat. The lethal effect of moist heat is due to denaturation and coagulation of protein. The advantage of steam lies in the latent heat that is liberated when it condenses on cooler surface, raising the temperature of that surface. In case of this process, steam condenses on it, increase its water content with the ultimate hydrolysis and breakdown of the bacterial protein. So in moist heat, there is a temperature below 100 degree or at 100 degree, and steam at atmospheric pressure, that is 100 degree Celsius, and steam at under pressure. So first is the temperature below 100 degrees Celsius, that is pasteurization of the milk, example of that. So in that the temperature employed is either 63 degrees Celsius for 30 minutes, that we call as a Holter method, or 72 degrees Celsius for 15 to 20 seconds, that is flash method. So followed by cooling quickly to 13 degrees Celsius. By the process, all the non-sporing pathogens are destroyed. So Coxella burnetii is heat resistant and may survive Holder method. Then in separation, the media such as Lowenstein, Jensen and Loeffler's serum are rendered sterile by heating at 80 to 85 degrees Celsius for half an hour on 3 successive days in separator. Then next is the vaccine bath or water bath. Vaccine of non-sporing bacteria are inactivated in special vaccine bath at 60 degrees Celsius for 1 hour. Then serum or body fluid containing coagulable protein can be sterilized by heat for 1 hour at 50 degrees Celsius in water bath on several successive days. Then temperature at 100 degrees Celsius, that is boiling. Vegetative bacteria are killed immediately at 90 to 100 degrees Celsius, but sporing bacteria require prolonged period of the boiling. So hard water should not be used. The sterilization may be promoted by additional of 2% sodium bicarbonate to the water. The disadvantage of this, spore cannot be destroyed. Then steam at atmospheric pressure, that is steamer. An atmosphere of free steam used to sterilize culture media which may be decomposed if subjected to higher temperatures. Coach or unload steamer are used. It is an inexpensive method. So single exposure of 90 minutes is required. So steamer made of tin copper cabinet with wall of suitably lag with lid is conical, then perforated tray are fitted in that and over the water level. Then tyndallization or intermittent sterilization. So it is used for the media containing sugar or gelatins. An exposure of 100 degrees Celsius for 20 minutes on 3 successive days. Reason, the first exposure kills all vegetative bacteria. The spore will germinate since they are in favorable medium. Then they will then be killed on the subsequent occasions. Then steam under pressure, that is autoclave or steam sterilizer, which are most widely used in the dentistry. The principle of steam sterilizer is that water boil when it is vapor pressure equal that of surrounding atmosphere. Hence, when the pressure inside closed vessel increases, the temperature at which water boils also increases. Then types of autoclaves, that is laboratory autoclave, hospital dressing sterilizers, rapid cooling sterilizer, boil and instrument sterilizer. Even a domestic pressure cooker can be used as an autoclave. So in autoclave there are different temperature are used. These are some different temperature with at a specific pressure and time. There is a 130 4 to 130 degrees Celsius at a 30 psi pressure for the 3 minute over the 20 cycles. Then 126 to 129 degrees Celsius temperature at 20 psi for 10 minute over the 30 cycle per minute. 121 to 124 degrees Celsius, the pressure is 15 degrees, 15 psi, and minimum holding pressure is time is 15 minute for the 40 cycle per minute. And 115 to 118 degrees Celsius, the pressure is 10 psi for 30 minutes, and overall cycle time is 50 per minute. So advantage of this is most rapid and reliable method, and the disadvantage is rust carbon steel denatures certain chemical such as epinephrine in local anesthesia cartridge. It melts the plastic, oil, and petroleum product, resist steam penetration. It cannot penetrate tightly wrap and pack loads. So installation, there are radiation also used that in that non-ionizing and ionizing radiation. So first is ionizing radiation. In that X-ray, gamma rays, cosmic rays are used. It is highly lethal to DNA. Very high penetrating. It has a very high penetrating power. Referred to as a cold sterilization as no appreciable increase in the temperature takes place. So gamma radiation used in commercial plant for sterilizing plastics, syringe, swab, catheters, animal feeds, oils, cardboard, fabric, greases, and metal foils. For example, cesium 137 and cobalt 60. These are the most commonly used. Then non-ionizing radiation, electromagnetic wave with wavelength longer than that of the visible light used, absorbed as a heat. Thus, infrared radiation can be considered as a form of hot air sterilization, used for rapid mass sterilization of pre-pack items such as syringes and catheters. Ultraviolet radiation used for disinfecting enclosed areas such as laboratories, operation theatre, and entryways. Then ultrasonic and sonic vibrations. Ultrasonic and sonic waves have bactericidal powers. It has a high level of auto acoustical energy produced by the phenomenon known as a cavitation in liquids. Corresponds to the formation and rapid small cavity through the entire liquid. The shearing force at 20,000 produced by collapse of cavity which breaks the bacterial cell wall and allows intercellular content to spill into the fluid. So microorganisms vary in their sensitivity to them, and the survivor have been found. Hence, of no practical value for this ultrasonic and sonic vibration. Then chemical agents. In chemical agents, the properties for the ideal antiseptic or disinfectant should be they should have wide spectrum of activity and be effective against all microorganisms by via bacteria including spores or viruses, protozoa, and fungi. Be active in presence of organic matter, be effective in alkaline as well as acidic medium. So and it should have speedy action, have a high penetrating power, and it should be stable. It should be compatible with other antiseptic and disinfectant, that is and also not corrode the metals, then not cause the local irritation or sensation, then not interfere with healing, not be toxic if absorbed into circulation, be cheap and easily available, be safe and easy to use, such as ideal chemical is yet to be found. So first is alcohols. Ethyl alcohol and isopropyl alcohol are the most frequently used. They are used as a skin antiseptics. Then denaturing bacterial proteins, no action on the spores. So concentration of the 60 to 90% in water to be effective. The protein slows its action. 1% of mineral acid or alkali enhance the action. Isopropyl alcohol is preferred as it is better fat solvent, more bactericidal and less volatile, and used to disinfect clinical thermometers. Methyl alcohol effective against fungal spores. Its vapor toxic inflammation. Its vapor are the toxic and inflammable. So it is used to treat the cabinets and the incubators. Then aldehyde. In that formaldehyde and glutaraldehyde. First is a formaldehyde, active against amino group in protein molecule. Then it is a bactericidal, sporocidal, and lethal effect on the viruses. Then used to preserve the anatomical specimen for destroying anthrax spore in hair and wool. Then 10% formalin with 0.5% sodium tetraborate for sterilization clean the metal instruments. 8% of aqueous formaldehyde solution requires 10 hours for the sterilization and disinfection for the 30 minutes. So then glutathione action similar to formaldehyde. The specific effect against the tubercle bacilli, fungi and viruses. It is a less toxic and irritant than formaldehyde. So no harmful effect on the cement or lenses of instruments such as cystoscope or bronchoscope. Can be safely used to treat corrugated rubber anesthetic tubes, face masks, metal instrument, plastic endotracheal tube and polythene tubing. So the glutathione to form, that is alkaline and acidic. The alkaline 2% solution of alkaline glutathione require 10 hours for the contact time. It present as a sides and 3M germicides. Then acidic, it is found in the 1969. So shelf life is more than the alkaline glutathione. Then come to the halogens in that chlorine and iodine. So iodine is a bactericidal with moderate action on spore, widely used as a skin disinfectant, active against tubercle bacteria and viruses. Iodophores, the compound of iodine with non-ionic weighting or surface active agent. It is more effective than the iodine. Then chlorine and its compound, used as a disinfectant, disinfecting water supplies, swimming pools. For example, chloramine and halogen used to purify the drinking water. Also used in food and dairy industries. Then used commonly as a hypochlorites. It is used as bactericidal. Then if it against the viruses, and organic chloramine used as the antiseptics for the dressing wounds. Then phenols obtained by distillation of the coal tar between the temperature of 170 to 270 degrees Celsius. The Lister, the father of the antiseptic surgery, first introduced their use in the surgery in 1865. The mechanism of action of the phenol is they cause the cell membrane damage. At low concentration, they precipitate proteins. So it is a powerful microbial substance. Lysol and cresol, these are good general disinfectants, not readily inactivated by presence of organic matter, but toxic to the humans. So related chlorophenols and chloroxyphenols less toxic but are less active and easily inactivated by the organic matter. Both these group inactive against the pseudomonas. Then hexachlorophene is a potential toxic and should be used with the care, which is present in market or trade name as a physohex. So it has a high absorbing activity, hence Food and Drug Administration is against its use. Then chlorhexidine, relatively non-toxic skin antiseptic used as widely in dentistry. So parachlorophenol, the root canal antiseptic, low toxicity and increased bactericidal activity. So there is a gases, some gases are there, the ethylene oxide, formaldehyde gas and beta propiolactone. So ethylene oxide, it is a colorless liquid. It has boiling point 10.7 degrees Celsius, highly penetrating gas with sweet smell, highly inflammable, highly explosive if concentration in air greater than 3%. Explosive tendency eliminated by mixing it with inert gas like carbon dioxide or nitrogen. And its mechanism of action is it is acted by the alkylating the amino, carboxyl and hydroxyl and sulfhydryl groups in the protein molecules. It also reacts with the DNA and RNA. It is a toxic to human, effective against all type of microorganism, readily diffused through the many type of materials, used for the sterilization, heart, lung, machines, respirators, sutures, dental equipments, books and clothing. Not suitable for fumigating room because of its explosive property. Then formaldehyde gas, it is used for the sterilizing instrument and heat sensitive catheter, for fumigating wards, sick rooms and laboratories, for disinfecting clothing, bedding, furniture and books. The gas is the irritant and toxic when inhaled, and it can be nullified by ammonia vapor after use. Gas marketed at 37% aqueous solution called as a formalin. The fumigation of operation theaters. Windows and other outlets are sealed. Formaldehyde gas is generated by adding 150 gram of potassium permanganate to the 280 ml of formalin for every 1000 feet of the room volume. The reaction procedure considerable heat. Then heat resistant vessel should be used. So window and other outlet left unopened for the 48 hours. Then beta propanolactone, condensation product of ketone and formaldehyde. Then boiling point is 160 63 degrees Celsius. low penetrating power but more effective fumigating agent than formaldehyde. It is a carcinogenic. Then it is effective against all microorganisms. 0.2% of beta propion lactone used for the sterilization of the biological products. Then heavy metals and salts of silver, copper, mercury used as a disinfectant. The mechanism action is the cause of coagulation of protein and combined with free sulfhydryl group of the cell enzyme. The mercury chloride highly toxic. Then thiomersal, phenylmercury nitrate and mercurochrome less toxic and used as a mild antiseptic. Then silver salt have a limited use. Then copper salt used as a fungicides. These are some metal salts. Then instrument sterilization, in that cleaning, packaging, storage. In cleaning there is a hand scrubbing, ultrasonic cleaning. Then in packaging, cassette, sterilization bag, the storage cassette and cabinets. So dental unit, waterline and biofilm. Microbial biofilm form in small bore tubing of dental unit. Biofilms serve as a microbial reservoir. So primary source of microbial is the municipal water supply. Dental water quality, for routine dental treatment meet regulatory standard for drinking water. Uh, uh, Less than 500 coliform unit per ml of heterotrophic water bacteria. Colony count in form of in water from the untreated system can exceed 10 lakh coliform unit per ml. So in conclusion, the proper sterilization and disinfection of the instruments and maintaining as a strict personal and operative asepsis protocol can prevent the cross infection. So it always better to be safe than sorry. Thank you.